Bigelow Commercial Space Station. The Bigelow Next Generation Commercial Space Station was a private orbital space station under conceptual development by Bigelow Aerospace in the 2000s and 2010s. Previous concepts of the space station had included multiple modules, such as two B-330 expandable spacecraft modules, as well as a central docking node, propulsion, solar arrays, and attached crew capsules. However, it was also suggested that each B-330 can operate as an independent space station. Attaching a B-330 to the International Space Station or flying a B-330 alone have been suggested by Robert Bigelow. On 8 April 2016, NASA launched a Bigelow inflatable module and attached it to the ISS, where it has been tested for over 4 years. History. Early work at Bigelow Aerospace on expandable space habitats, with plans to eventually assemble them into on-orbit space stations, began in the early years after the company was formed in 1999. By 2004, plans made public included assembly of multiple modules into a manned space facility in low Earth orbit for both privately and publicly funded research and for space tourism. Two more formal concepts have since been made public. By 2005, Bigelow Space Station plans had been further conceptualized into Commercial Space Station Skywalker, or CSS Skywalker. In mid-2010, Bigelow announced their next-generation commercial space station, later named Space Complex Alpha. The initial dates for the Alpha Complex were not achieved. In January 2013, the Alpha Complex was specified to be an in-space assemblage of only two B-330 modules, with the first module, CSS Skywalker. The CSS Skywalker Commercial Space Station Skywalker was a 2005 concept for the first space hotel by Bigelow Aerospace. The Skywalker was designed to be composed of multiple Nautilus B-330 habitat modules, which would be inflated and connected upon reaching orbit. An MDPM multi-directional propulsion module would allow the Skywalker to be moved into interplanetary or lunar trajectories. In short, CSS Skywalker was an effort to build the planet's first orbiting space hotel, with a projected room rate of $1 million per night, and a hoped-for launch date for the first Nautilus module of 2010. Company challenges. Early assessments of the probability of success of the technology development and challenges of a commercial space station pointed to the importance of factors largely beyond Bigelow's control. For example, in 2005, John M. Logsdon, director of George Washington University's Space Policy Institute, said, "I have little doubt that the basic technology is likely to work. The issue is whether there is a transportation system that can get people or things or both up there." In practice, orbital launch plans were significantly delayed. First, after the Space Shuttle Columbia disaster in 2003, Bigelow had to compete with NASA for rides on the Russian Soyuz three-person rocket, a distinctly untenable position. In mid-2009, Bigelow announced they were continuing to develop a variety of space habitat architectures. Space transport. In 2008, Bigelow initially began talks with Lockheed Martin to potentially contract launch services on its Atlas V-401 vehicle for both crew and cargo launches. By mid-2010, Bigelow was actively pursuing launch options for its space station modules and crew capsules from two launch systems, the Boeing CST-100 capsule on a ULA Atlas V launcher, and also the SpaceX Dragon/Falcon 9 capsule/launcher combination. Bigelow offers Boeing, SpaceX, and other vehicle developers the promise of a sustained, large market for space transportation services. With the initial Space Complex Alpha, Bigelow would need 6 flights a year, with the launch of a second. In May 2012, almost simultaneously with the successful mission of SpaceX's Dragon capsule, launched by SpaceX's Falcon 9 vehicle to the International Space Station, Bigelow and SpaceX jointly announced that they were teaming to offer private crewed missions to space, promoting the Bigelow Space Station and SpaceX transport systems. In 2014, plans called for transport of humans and resupply cargo to the station to be via SpaceX Dragon V2, with a round-trip seat priced at US $26.05 million. Lease of the on-orbit stations was priced at US $25 million to rent one-third of a B330 module for 60 days. The B330 modules and any of several tugs were planned for launch aboard a Falcon Heavy launch vehicle. Space Complex Alpha. The Bigelow Next Generation Commercial Space Station was announced in mid-Minus 2010. The initial configuration for the 2014/2015 space assembly was 2 Sundancer modules and 1 B330 module, named Space Complex Alpha after October 2010. Bigelow began to publicly refer to the initial configuration, 2 Sundancer modules and 1 B330 module of the first Bigelow station, as Space Complex Alpha in October 2010. If the entire station is leased out, it could mean up to 25 launches per year for crew and cargo. In early 2013, Bigelow Aerospace started referring to Alpha as consisting of 2 B330 modules instead of 2 Sundancer and 1 B330. In October 2010, Bigelow announced that it has memorandum of understanding with 6 sovereign nations to utilize the on-orbit facilities of the commercial space station: United Kingdom, Netherlands, Australia, Singapore, Japan, and Sweden. A 7th country signed on in February 2011, the United Arab Emirates. In August 2015, Michael Gold stated that the timetable for the first B330 deployment is uncertain at the moment, since it is tied to the development of private astronaut taxis that can get people to orbit. With this projected to be 2017 or later, Bigelow expects to be ready when they are. In April 2016, the 2 B330s attached together was also questioned by suggesting that the first B330 might ideally be attached to the International Space Station, or that each B330 could operate. The first liftoff was targeted for 2020. All flights are currently on hold due to the temporary layoff of all Bigelow employees due to the COVID-19 pandemic. Orbital complex construction. In 2010, Bigelow Aerospace began building a large production facility in North Las Vegas, Nevada, to produce the space modules. The 16,800 into 181,000 SQFT facility will include 3 production lines for 3 distinct spacecraft, doubling the amount of floor space at Bigelow and transitioning the focus from research and development to production. Bigelow expects to hire approximately 1,200 new employees to staff the plant, with production commencing in early 2012. Construction would require 3 medium lift launches and 1 heavy lift launch. In October 2011, Reuters reported that Bigelow had pared its 115-member workforce to 51 because of delays developing space taxis needed to fly people to the outposts. As of 2010, on-orbit assembly of the Bigelow Next Generation Commercial Space Station components was projected to begin in 2014. As of July 2010, construction of the orbital complex was projected to occur in 7 principal steps, based on an operations concept that included the on-orbit addition of 2 Sundancer modules and 1 B330 module. Unit 1, Sundancer 1 module, with a pressurized volume of 180 cubic meters M3 unoccupied. Unit 2, commercial crew capsule, arrives with Bigelow Aerospace astronauts to set up Sundancer 1 and carry additional supplies. Unit 3, supplemental power bus and docking node. Unit 4, Sundancer 2, Dancer 2, 2 Dancer 2, and Dancer 2, Dancer 2. Unit 5, second commercial crew capsule, brings additional crew and supplies and provides a redundant method for crew return to Earth. Unit 6, B330, larger volume module 330 M3. Unit 7, third commercial crew capsule, brings additional supplies and provides a double redundant robust solution for astronaut re-entry. Commercial leasing. In January 2013, Bigelow announced that they would sell naming rights to the Joule B330 module Alpha complex for US $25 million per year. In 2014, Bigelow announced that prices for human access to the space station were expected to be US $26.25 million aboard a SpaceX Dragon, or US $36.75 million aboard a Boeing CST-100. The price for a 2-month lease of 1/3 of a module, approximately 110 cubic meters, 3,900 cubic feet, was provisionally set at US $25 million. Technical. Docking system. As of 2007, Bigelow was planning to equip its expandable space modules with both a Soyuz-style docking system on one end and a NASA standard low-impact docking system on the other. The available docking port options for the next-generation commercial space station have not yet been released. Test program. The human-in-the-loop testing of the Environmental Control and Life Support System (ECLS) for Sundancer began in October 2010. By January 2013, the Bigelow Expandable Activity Module beam pressurized module was under development by Bigelow Aerospace, being purchased by NASA for attachment to the International Space Station. The beam arrived at the ISS on April 10, 2016, was berthed to the station on April 16, and was expanded and pressurized on May 28, 2016. The initial plan was to test the expandable habitat technology for at least 2 years. During its flight mission, NASA has been testing and monitoring the module's structural integrity, leak rate, radiation dosage, and temperature changes. The module has been performing well, and in October 2017, it was announced that the module would stay attached to the ISS until 2020, with options for 2 further 1-year extensions. The module is being used to store up to 130 cargo transfer bags in an effort to free up additional space aboard the station. Launch planning. Potential launch options are in the mid-heavy lift launch system class of launch vehicles, where Bigelow has now negotiated arrangements with 2 commercial launch providers. As of January 2013, both SpaceX using the Falcon 9/Dragon and United Launch Alliance/Boeing using the Atlas V/CST-100 have signed to deliver launch services to Bigelow Space Station Alpha. In February 2011, Bigelow announced that it would begin launching its unmanned space station modules in 2014 from Cape Canaveral using Atlas V launch vehicles. In addition to the Atlas launches for the expandable modules, Bigelow had reserved a single 2014 launch on the SpaceX Falcon 9 rocket, but that launch had not taken place as of early 2019. As of August 2011, press reports indicate that Bigelow will launch at least some of their crews to the station on the human-rated Atlas V utilizing the Boeing CST-100 7-person space capsule. In April 2016, Bigelow signed an agreement with United Launch Alliance to launch the first B330 module in 2020 using an Atlas V rocket. In October 2017, Bigelow Aerospace and United Launch Alliance ULA announced they are working together to launch a B330 expandable module on ULA Vulcan launch vehicle. The launch would place a B330 module in Earth orbit, and after outfitting it would be boosted to low lunar orbit by 2 further Vulcan ACES launches by the end of 2022 to serve as a lunar depot. As this announcement stated that only a Vulcan had the performance and fairing capacity needed to launch a B330, it appears that any Atlas V launches would be for crew rather than B330 modules. The timeline may be aspirational, as ULA have indicated that the Vulcan will transition to using the ACES upper stage around 2024. Long-term proposals. In late 2010, Bigelow indicated that the company would like to construct 10 or more space stations and that there is a substantial commercial market to support such growth. Future space station concepts. In 2010, Bigelow said that second orbital station Space Complex Bravo was scheduled to begin launches in 2016 and go into commercial operation in 2017. This complex would consist of 4 B330 modules. Bigelow has publicly shown space station design configurations with up to 9 B330 modules containing 2,803 1/5 of habitable space. The conceptual configurations are listed below. Advanced Medical Facility 3003 9 B330 modules, 3 propulsion buses with docking node, 3 crew capsules. Biological Containment Station Low Earth Orbit 2803 habitable, 660 remotely controlled. Biological Research Station Low Earth Orbit 2003. Deep Space Complex 1320 4 B330 modules, 9 propulsion buses with docking node and 3 docking ports. Lunar Depot Ares 990 3 B330 modules, 4 propulsion buses with docking nodes. The entire station would land directly onto the Moon. It is intended to hold 12 astronauts but is capable of holding 18. Near the lunar base, there would be a solar array field. A model of this concept has been built. Mars Exploration 1320 4 B330 modules, 3 propulsion buses with docking node. Resupply Depot Hercules 8303 announced Oct 2010 6 B330 modules, 3 BA2100 modules, 9 propulsion buses with docking node, and 3 crew capsules.